Hey mates, so in this video we're working on the GEQ500 from JLM Audio. This is a kit from them. This is a 500 series module. I've done some kits from them before and they are fantastic. I always enjoy working on them. They're very well thought out and very well put together. The first part we're going to be working on is the DOA, or the discrete op amp sockets. Now we've got these little cups here we're going to be dropping in. There's probably more one way to do this, but I just like to drop them in like this and then throw a little bit of solder and let that heat up the area and let it flow in. You don't really want to put too much. If you're kind of concerned, you can always flip it to the other side, but sometimes they drop out. It's kind of a pain. So with these, usually a little bit goes a long ways as far as solder. We got those 4 up at the top. We'll do these 2 at the bottom. Use a little bit of flux to help reflow the solder. And now we're going to get to the 12-pin connector. This connects into the control board. Usually I like to just tack in a couple of corners, make sure it's all flush, and then go in afterwards and take care of all the rest of the pins. Here I'll also like to throw a little bit of flux on there just to make the solder flow easily and not have to go back and redo my work. Next up is the resistors. Now here we did the 10 ohms first. I like to test the resistors out before putting them in. I know you can read the color code and everything like that, but I have a hard time reading those, and I don't have any difficulty whatsoever reading my multimeter. So I usually just trust that over my eyesight or what's written on the side of the resistor. Go ahead and throw those guys in, flip it over, solder it in, easy. Take them, trim out the nasty bits. Next up is the 4.7K. Again, we're going to test this just to make sure that it's the right component. Now, funny enough, when I was working on this, I did get a component wrong, and I don't remember exactly where it is in this video, but I had to go back and fix it. It was the only component I did not test, so lesson learned. All right, we're going to go in and put these guys in. I think at this point, I kind of just started loading it up with the resistors. There's quite a few of these, so just kind of went in and dropped them all in. All right, now looks like more resistors. Go in here, solder these spots in. Pretty straightforward. Now, there's quite a few here, so we'll have to go through. Looking over, there are spots where I did get solder in. It's good to use a little solder wick to help remove that. I did remove most of the edits of me having to use solder wick to remove solder, so you will see some go into holes and then later see in the video that it's just not there. That's called movie magic. Go ahead and get these guys. Get these ones up top. Get this spot in this. Trim those bits off. A lot of trimming, a lot of soldering. Once you get all that snipped off, we'll move on to the next component, which is going to be the IC socket. Now this is the 8-pin dip socket. With these, everyone has their own little way that they like to put it in. I enjoy just tacking in the corners, and then once I'm happy that it's all flush and on there good, I'll do the other pins. Next up is the 47 picofarads. There's, I believe, 4 of them. I usually snip them out of the tape just to keep that stickiness off. The location is pretty easy, just around that top area around the dip. Once you got those in, go ahead and flip over and solder them in. Go ahead and snip off the pieces, the leads. And next up is the 1 microfarad caps. First I thought these were the electrolytics, but then I looked at the picture and realized that they are not. Once you got those in, you know what to do. Solder them in. Trim the leads. Next is the 12-volt relay. This one sits up near the edge connector. Now here, I took a bunch of solder and just kind of put it as close as I could so I could have a bunch in that area. Sometimes I'll do that where I'll just roll a chunk of it, because once it liquefies onto the iron, you have that little bit of time before the flux burns out. Even here, I went ahead and just added some more to smooth out the joints. Next are the fuses. These will sit in the back. Pretty easy. They're just like caps. They're not polarized or anything like that. So far, none of the components we've really dealt with are polarized. Now we've got our 10 microfarad and our 100 microfarad caps. These are kind of all the electrolytics. I think I just went ahead and just threw these guys all in so I could just solder them all at once. No sense in doing a pair and then another pair and so on and so forth. Once I got those soldered in, go ahead and trim the leads off. Next is the 470 microfarad cap. This just sits in the back. Pretty easy guy to solder in. Alright, next is popping in the IC. Gonna go ahead and just give it a good cleaning now. Just my typical method for cleaning is to use these clean room wipes, and I'll cut them up into little smaller pieces. They come in larger sheets, and then I'll just put alcohol in there and soak it up and just run that across with a brush. Kind of go back and forth between using the brush and just using an alcohol soaked clean room wipe. The wipe kind of helps keep the alcohol in one spot, and it also helps kind of keeping your brush from just, you know, having dirty mop water. Now we'll definitely need to clean this a little bit more, but I just wanted to give it a nice little quick clean just to get things going. We'll pop in that IC. A little more cleaning. And next up is, we're going to go ahead and skip over the DOA op amps, and we'll go ahead and put in the transformer. So with the, you might notice some continuity errors here. So originally I had soldered the pins for the transformer in, and then later on went and put the transformer in. But I found it was actually a little bit more difficult, and if I just did the transformer and the pins at the same time like we are here, just having the transformer itself seat the pins in their spot, it was quite a bit easier. So the process is just going to be, once the transformer is in, we'll make sure that the pins are nice and flush, and then just pop it in and solder it like normal. Alright, so this is the control board. This is the second out of the 3 boards that comes in the kit. Again, fairly straightforward with the components. Everything for it is in its own little bag, making it really easy to sort everything out and make sure you get everything in the right spot. First off are the 1N914 diodes. There's 4 of them. For diodes, it always depends, but typically I like to use the lead bender for these just to try to get them to be even, but your mileage may vary. Don't forget these diodes are polarized, so make sure you solder them in the correct direction. Once you get them in, you'll want to do the good old solder job. They're all right next to each other, so it makes it pretty easy. After that, you go ahead and cut those leads off. And we'll go ahead and start on the next resistor. Now at this point, I kind of just started putting all the resistors in and then just soldering them in afterwards. Again, I like to use my multimeter and test them before I put them in just to make sure I'm getting the right one in the right spot. If you notice, the first one I did not measure, and it turns out that was the wrong one that I mentioned earlier. So definitely pay attention to the resistors and where they're going. One nice thing to do is just to do them one at a time. Double check your spot. What's really great about the JLM projects is the map that's given on the build site, so you can go through and tick off each component that you need to do. It's a little easier than using a spreadsheet or other ways of going about it, and I enjoy the visual aspect that you can see exactly where it is on the map. Doing the second set here, testing these resistors as well. Another set of resistors. Again, generally it's not a good practice to do what I'm doing, where you put in a ton of components and then go back and solder them all. A lot of people don't like to do it that way, and with good reason. I just kind of don't learn my lesson and just kind of try to struggle with it. Create challenges for myself to overcome. Now we'll go ahead and solder all these in. One benefit, obviously, you can see is that they're all next to each other, so it's kind of easy just to run your iron by. All right, we'll go ahead and trim off all these leads. Do the other row. All right. Go ahead and trim those leads. Do a little touch-up work with the iron, just to make the joints a little nice. And here's a good spot where it actually got a little messy. All right. Got a few more resistors to put in. Once got those soldered in, flip it around, get the other spots. Trim the leads. Now put the dip socket in. Same method as before, attack in. Now here I did bundle up a whole bunch of solder there. You can see, just to help give me a little bit of solder in that area with the flux so I can tackle it. And we'll do the rest of the leads here. Next up is the capacitors. As 47 picofarads. There's 4 of them. They all sit around the dip package again. Once you got those in, go ahead and solder. Trim the leads. Next is the 1 microfarad caps. These are pretty easy to spot. It's just 2 of them. Pretty quick and easy to pop in and solder. Once you have them soldered in, go ahead and trim them. For the relays, what I did was I went ahead and placed them all into the board and didn't tack solder them or anything like that. But I took a clean room wiper, you could take a sheet or anything, and you do the old tablecloth routine where you'll just pull it out underneath, and now they're all situated and oriented, and you can just go through and solder them. And I still went ahead and did the corners of each one just to make sure that they were all going to sit flush. Much easier to fix with just 1 instead of 10. Once I got them all soldered in and good, I just double check, make sure everything's flat, and then just kind of drag solder through, getting each one of these pins. Once those are done, the next component is going to be this transistor, just a single one. Mine, the leads were straight, but the footprint was a triangle, so I had to bend one leg out. Your mileage may vary. Doing a little cleanup. Next comes meeting these 2 pieces up. Now the edge board had the pins already soldered in. Took those jumpers off and assembled it through the control board, having it meet up with the header already. Now all the pins are already aligned in and exactly where they need to be. Just go through, drop some flux, and solder all the pins in. Once that's done, go ahead and take that board out for now. A couple of more components. Next, we have the headers. This connects the control board to the filter board. Now for these, I just basically popped them in and they sat flush against the back. And it really I just kind of soldered them here. They wasn't really a big deal. Went ahead and put the switches in. Now this is also the RGB LED. Fitting that in loosely and waiting for it to marry up to the second board. That way I can be happy with where it's landing internally. Now with these switches, I just soldered the middle pin just so I could have a little bit of wiggle room in case I needed it to move in any direction. Now we're going to move on to the filter board. Again, there's going to be some continuity because there's a little bit of 2 different versions of this. I discovered that when building this, you absolutely really should put the spacers in place before putting the faders in. I made the mistake of doing it the other way around, and what ended up happening is the faders dropped in, but they were offset, and it made it really difficult to get the spacers back in, as well as putting the LEDs. It was kind of a pain. So I can't stress enough to make sure you have those in first before putting them in. That'll allow you to guide the faders in. Now, if you'll see here, the fader actually, the box outlining it, the footprint on the board, you can see it all. Prior on the mistake one that I did, the first one, I didn't see that line. So this is pretty straightforward process of just putting them in, making sure they're nice and seated well, the pins aren't bent, nothing's going to be crooked or misaligned. Now once I got all the faders on, I did the same thing as I did with the relays. Just went ahead and put the sheet there so I could keep them on and lay them down. I didn't really pull the sheet out because I was kind of worried that it would loosen them up. And first I went through and just tacked each one of the legs in on just one side. Once those were in, I went along the edge and checked each side, tried to make sure each one was flush. As you can see, some of these were a little off, but just going through and paying careful attention to each one, making sure that the housing is sitting on the board firmly. Helps guarantee that it's not going to rub against the panel and you'll have a nice clean movement. Once that side was done, basically repeated it on the other side. Now again, just doing one of the leads. There's 4 leads altogether. I'm just going to do this side first, so we'll be able to adjust anything. Once everything's good and it looks fantastic, just do all the rest of the leads to make sure everything's mechanically and electronically secure. Go ahead and look along the edge there. There's a couple. Could use a little TLC. And with that, we'll go ahead and fill in all the rest of the solder holes. Okay, so now we're going to marry the filter and the control board up. We're going to place all the pins and headers in. Now, I did do this 2 different ways of soldering these headers in to the control board and then putting the 2 together. Here you're seeing that they're both just loosely put in, and we're pressing them together, using the spacers to hold everything in place, and then we're going to go back and just solder all the pins in. I like to do this a lot of the time, especially with front panels and stuff like that, because you'll find that it's a lot easier to let the panel and the environment kind of dictate where the components are going to be and then solder it in, versus soldering something in and then trying to move it into place so that it can fit inside that environment. It's just kind of common sense, but I still have to remind myself of it, as was the case here. There goes the RGB LEDs, trimming those off. All right, last step is going to be putting it together. First we'll take the edge board, fit it in with the control board and the filter board. Should have those already married up. Not terribly complicated at this stage of the game. It's probably the easiest part. So overall, I really enjoyed this build. I highly recommend it to anybody. A newcomer, it's very well detailed and laid out. You can appreciate it. And then a seasoned builder is just going to appreciate that attention to detail. The only real hangups that I ever ran into are with the LED. I couldn't really get the lens to stay in place, so I ended up just using a little bit of hot glue. And that works great. It's better than using any permanent type of glue, and it's very easy to remove if you decide you need to take it off. Now, the addition of the SMD DOA amps is really cool. These are the discrete op amps that are SMD. This is the first time I've ever encountered those. They're really cool. I like the idea. It's given me a lot of ideas as well. Overall, this thing is just a beautiful little piece of electronics, a great kit, and a really nice graphic EQ. If you like more content like this, don't forget to like and subscribe, and see you next time.